Mr. Herman here with your remediation for linear modeling pretest. So since yesterday we looked at exponential modeling, we're going to kind of do a little review of our linear modeling before we move on to comparing exponential and linear functions next week. So we're going to go and start off with just identifying, does the scenario model a linear function, and how do we know? So number one here is Mr. Herman pays $4.99 each month for his ESPN Plus membership. Okay, so since I pay $4.99 each month, this $4.99 per month is a constant rate. Okay, because I pay it each month. It does not matter anything else, how long the month is, or how much money I make, or how much I watch. I pay $4.99 every single month. Okay, so this would be a linear function. Okay, so go ahead and try number 2 on your own, and then we'll check it in a minute. All right, so Mr. Gibson earns 0.15% interest on his savings account each month. So we're looking here at our 0.15%. And if you remember from what we talked about yesterday in exponential modeling, that percent says that we're going to have percent growth is going to always be exponential. Okay, so this percent growth or decay, okay, in this case it's growth, but our percent growth means exponential. Because what percent growth means is that if I have more money, I'm going to make more money. If I have $100, I make 15 cents. If I have $200, I make 30 cents. This is not a linear function since it's exponential growth. Okay, it's not a constant rate of change. All right, so we've been able to identify if it's linear or not linear. Let's move on to writing a linear equation. So I'm going to jog our memories of something that we've seen a few times this year. It is the equation for a line. Okay, one of our favorites, y equals mx plus b. Okay, if there's but one thing that you remember, which hopefully it's more than one, it is that the equation of a line is y equals mx plus b. But it's not just enough to know that equation, we got to know what everything means. So our m is our slope, and our b is our y-intercept. So we're going to go ahead and look in these two problems here and figure out what the slope and y-intercept is and plug them in. So a new iPhone 11 costs $850. The monthly fee to use the phone is $75 per month. How much does it cost to own and use an iPhone 11? Okay, so we got to figure out those two numbers. We got 850, we got 75, we also got 11 in there. But I'm going to say that 11 doesn't matter a whole lot because it's just describing the iPhone. Okay, so that should not come up in our equation anywhere, even though we see that number. So we've got this number here, this 850, and then we see this 75. Now we have to figure out which one is y-intercept and which one is slope. When we talked about exponential functions, we talked about initial values. In that y-intercept, it's still the initial value. So if I'm looking at my iPhone, my initial value that I have to pay for it is $850. Okay, so B is going to equal $850. That's our initial cost. And then our slope is 75, because it's the cost per month. Okay, that word per month, when it's with dollars, not percentage, when it's with dollars, typically means a linear function, and that's the slope. So if we put those into our equation here, we get y equals 75x plus 850. All right, so go ahead and try number 4 on your own. All right, so let's take a look at this one. We got Miss Kirchhoff has taken out a loan for $500, and each month she pays back $75. How much does she have left to pay back from the loan? So once again, we got to look at the numbers that we've got in our problem here. We've got a loan of $500, and she's paying back $75 each month. Okay, so let's think about our initial value. So we got our 500, we got our 75. Her loan is starting at $500, so if it's starting at $500, that is our initial value. Okay, so 500 is the initial loan. Okay, M is talking about that rate, and she's paying back $75 each month. Okay, now we got to be careful here. $75 pays each month. Does that make the loan be more or less? Since she's paying it back, it means it's less. So her slope is going to, her M is going to be negative 75. Okay. Another word that helps us realize that this has got to be our slope is this word each. So pays the dollars each month, $75 each month. We're going to plug that into our equation of y equals negative 75x plus 500. Okay. Now, in 5 and 6, we're doing some interpreting, describing what they represent. Okay. So, we're going to use our same equations, and we're just going to describe what each part of the equation tells us. So we've got y equals 75x plus 850. That 75 is the phone cost per month. And then we've got the 850. It's the initial cost of the phone. All right. Now we need to describe, so we've got our y-intercept and we got our slope. Let's go check our x variable. So this is real important of what is it measuring? Because it looks like we're measuring two things here. We're measuring months, so how long we've got the phone, and then the cost. Okay. So in this case, our x values, 99% of the time, if we see time in a problem, time is going to be our x value. So that's months with the phone. All right. And then our y value, which is typically going to be responding to our question, how much does it cost? That's our question. So y is going to be cost to own and use the phone. Okay. So go ahead and work on number 6 on your own, and then we'll check it. All right. So we're back to number 6. Once again, looking at all 4 components of this equation. So our negative 75, that is the loan payment each month. Notice how this is real similar to what we said above. Okay. Then we have our $500 initial loan. Then we got to go to our x's and our y's. It's a little bit different from what we have seen so far. We haven't really described these much. But let's take a look at x. Once again, we're thinking about time. If I see time in my problem, I'm thinking automatically that's got to be my x value. Okay, I'm an independent variable. So each month. So x is months paying the loan. And then y, what's our question? How much does she have left to pay back from the loan? So the amount of loan left. All right. Now with all these money problems with the linear functions and the exponential functions, we'll get you taking Mr. Gibson's Econ class pretty soon. But go ahead and work on the remediation notes for today for linear modeling before you take the post test.